Is it working? Okay. Improper integrals are going to be integrals that go from some number to infinity or even like negative infinity in theory. When you have functions like this that approach like a value like say 0, you can find that area. It's considered convergent versus divergent. So for the same reason, yeah, so for the same reason, if you remember like series, like finding the sum of certain, it's like the exact same concept. We're just doing it with calculus. So we have to use limits to find the amount instead of like a cutesy little formula that we had in algebra 2. So you just take the limit as b approaches infinity instead of, because you can't plug in infinity, but you can with limits, you know. So certain things will converge and certain things diverge, and that's kind of up to you to know. If there's like a horizontal asymptote of some kind, it's going to converge, and if not, it's going to diverge. So anything, any x to some positive integer, or I should just say any power that's greater than -1, integer greater than -1, that's going to diverge. Like x squared, x cubed, x to the 4th, those are all going to diverge. But if the exponent is negative, like this one, then it's going to converge. Because when we integrate, we get 1 over x, and that converges. So let us practice this one. So the first thing you're going to do is just integrate the function normally. So this is like the integral of 1 times x to the -2 power. And we're going to add 1 to the exponent, which is going to give us -1. And then multiply by the reciprocal of that, which is going to give us -1. And then we can't do this, really, because we can't plug in infinity. So we're going to find the limit as b approaches infinity of -1 over x from 1 to b, which is basically the same thing. So plug in b in your mind, plug in infinity. What happens, or what is the limit if this is a b, like 1 over b? Like if this is, here, let's look, see. The limit as b approaches infinity. If this is negative, let's say we plugged in b. Oh. Okay, -1 over b. If b is infinity, what does this amount approach?
Like -1 over infinity, so like a
very small number. Right, like and so we say 0. Yeah. So this is 0. And then you would subtract -1 over 1, which is just -1. So this simplifies to +1. Typically, you're going to get like something about a 0, usually. Sometimes if there's e's involved, it might not be 0, but typically that's what happens with the x's. Okay, now look at this one. Do you know how do we integrate 6 over x?
Can we use natural log of 6x?
Yeah, well, 6. So like 6 natural log x.
Oh, that's right.
It's still natural log. You're not wrong.
Now, what happens if you plug infinity in here? What's the natural log of really big number?
A really big number.
Okay, so it's not going to converge, right? So
it's
this diverges.
We just say diverges.
Indeed.
So it's like divergent.
Indeed. Yeah, I guess you could say like the integral is divergent, or it diverges.
On, like, the test, I say it's divergent.
That's fine. Same thing. They're different parts of speech. Divergent is equally good. All right, what about this one?
So that's going to be 3 natural log.
No natural log for this one.
We can't cube it. Okay. So let's do.
This is like 3x to the -3. Yeah.
And then add 1, so that's going to be -2, and then reciprocal -2. So it's just going to be -2x squared.
But we have the 3 too.
Yeah, but when you reciprocate it, doesn't it just make it 2? Reciprocate?
No.
No. It doesn't.
No.
Wait. Subtract the 2 2/3 times 3. Negative 2/3.
We're
times
multiple.
3.
So 3 is our constant. It's there, and then we're multiplying by the reciprocal of -2. So 3 over -2.
Oh, I don't know why I was thinking it was something. Okay, sorry.
Okay, then we can't plug in infinity, so we're going to find the limit as b approaches infinity of this. This is like all over x squared, I should say. It looks unclear.
I think we're killing Nick.
All right, so if I plug in b,
Yeah.
I get this.
So it converges.
Do you want me to open the door for the dollars?
Not particularly, because I'm teaching math, but I guess so.
So it goes to 0? B
Well,
goes
that was funny because it was like.
So this whole situation right here, if b is a really, really big number and then we square it and then we do this, it's still 0. So this is 0. And then this becomes, what is this when you evaluate that?
-3/2.
So this is going to be plus 3 over 2.
Yay!
And this is going to be just 3 over 2.
I don't understand why that was 0. So if you plug infinity in for b.
Like think if you plug in like 100 and then 1,000 and then 10,000, that number is going to get smaller and smaller and smaller until it's basically 0.
Yeah, okay.
I got a 20.
Now when there's e's, some of the e's converge and some of the e's diverge. If the exponent is a negative exponent, then it'll converge, and if the exponent's positive, it'll diverge. So since this one's negative, we could rewrite this like this. Oops, you can't see that.
No.
I can't scroll over. Oh my god, I hate my life.
Whoa! I'm gonna have to report you to the guidance counselor.
You're funny. Okay, there we go. And so it's the same kind of situation if this is like a really, really big number. All right, so but before we do this, let's not do that yet. Let's integrate this. Do you remember how to integrate e's?
Yeah.
So that'll be like -2e or negative x.
Yeah, good.
She's cute.
So 0, b, and then we're going to do limit as b approaches infinity. So now I'm going to rewrite it. So this is -2 over e to the b, and then minus -2 over e to the 0. And this limit guy goes here. Limit b approaches infinity. I forgot him. So if b is infinity, e to the infinity is super big number.
Which is just a big number.
So this is going to become
A small
0.
Yeah.
Then what's this number?
That's like 2
-2
point
over
something.
No, it's not 0.
What?
1.
-2 over 1, so 2.
So plus 2, and then this is going to be 2.
Anything with 0 power is 1.
Indeed.
Are we running today?
We ran that right there. It's not going to be 6. It's going to be, well, it fell.
Well,
It's not 6,
it's not
because when you integrate, the rule is backwards. It's going to be
It's gonna be
3 over 2,
3.
e to the 2x.
You do the reciprocal.
Yeah, so the reciprocal of the
Is
derivative.
So,
Yeah, like
yeah.
we get 2's.
So you get 2,
It's
so it's 1
it's
half.
just the reciprocal of this constant.
Yeah,
Oh.
times that.
Okay.
Okay, now if we plug in b, I get 3/2 e to the 2b, and then minus 3/2 e to the 2 times 0. If b is infinity, what is this?
Infinity. A great large number.
So it's not going to converge, so you're going to say
Divergent.
diverges or divergent. Okay. What about the last one, convergent or divergent?
Don't we have to find
Divergent. It's negative. Oh no, it's convergent. It's just
Converges because it's
kidding.
negative.
Yeah.
Yeah, you can tell if this is negative constant, it's going to converge. If it's positive,
It's gonna diverge.
going to diverge. So what's the integral then?
The integral is negative
2
negative 2.
e to the negative 2x.
Okay. So 0b, and then in front here we put limit as b approaches infinity. And then this is going to be
0
negative
plus
2 over
Um,
e to the
2.
2b, because I'm going to plug in b,
Yeah, that's right.
and then minus negative 2 over e to the negative 2 times 0. And then I forgot my limit again. Let's just put him
so
here.
it's just 2?
So this is
That's gonna be 0.
2,
So
and we get, actually,
What?
it's not. Yeah, it is. Just
No,
kidding.
it is.
Yeah, it is.
Don't
Wait, why is it?